This peripheral nervous system highlight screencast concerns the autonomic nervous system, which pertains to those peripheral nerves that innervate viscera. Recall that there are two types of efferent neurons in the peripheral nervous system. Somatic efferent neurons innervate skeletal muscle. Visceral efferent neurons innervates cardiac muscle, smooth muscle, or gland. Visceral innervation is collectively referred to as the autonomic nervous system. Chiefly, it's the visceral efferents. It also includes the general visceral afferents. There are two neurons in the visceral efferent pathway. The first neuron is located in the brain or spinal cord. The second neuron is located in an autonomic ganglion. The term autonomic refers to the fact that viscera generally, but not always, operates below the level of consciousness, self-rule situation. Visceral efferent innervation involves two neurons from the central nervous system to the target organs. The first neuron is named the preganglionic neuron. The second neuron is named the postganglionic neuron because that second neuron is located within autonomic ganglia that receive synapses from the preganglionic neurons. The synapse within the ganglion always involves acetylcholine as a neurotransmitter, but the synapse of the postganglionic neuron to the target organ may involve acetylcholine in the case of cholinergic neurons, but it may also involve norepinephrine in the case of adrenergic neurons, norepinephrine being noradrenaline. There is a one-to-many relationship for visceral efferent innervation. It is said that there are more neurons within the wall of the gut than in the entire spinal cord. There is an economic advantage to shifting neurons out of the central nervous system, where volume is at a premium because the neurons have to be surrounded and protected by bone, and shifting neurons into the body cavities where volume is plentiful. This shift works well for viscera, which do not require precise central nervous system control, such as skeletal muscles need. Viscera tend to operate en masse. That is, you contract the whole bladder to urinate, and so you don't need discrete control, and therefore you don't need these neurons within the central nervous system. This cartoon represents a segment of gut wall. The gut lumen is lined by villi, and the wall of the gut contains circular and longitudinal smooth muscle. There is a submucosal nerve plexus and a myenteric nerve plexus within the gut wall. Collectively, these plexuses may be referred to as the enteric nervous system, which would be a subdivision of the autonomic nervous system. Within the plexuses, postganglionic neuron cell bodies are evident microscopically. The microscopic ganglia are called terminal ganglia. The autonomic nervous system is divided into two divisions, a sympathetic division and a parasympathetic division, based on these criteria. The sympathetic division is concerned with fight or flight. That is, when the brain perceives a situation that is life-threatening, it needs to prepare for great expenditure of energy either to combat or escape the threat. The sympathetic nervous system is activated. Thus, sympathetic nerves are distributed to the whole body. Even so, the preganglionic neurons are restricted just to the thoracic and craniolumbar regions of the spinal cord. Synapses on target organs are generally adrenergic. That is, the postganglionic neurons release norepinephrine as a neurotransmitter at the target sites, which would be smooth muscle, cardiac muscle, or gland. In contrast, Parasympathetic neurons are concerned with routine visceral activities such as urination, defecation, etc. The parasympathetic nerves only go to the body cavities or to the head where they supply glands or constrictor muscles in the iris. The parasympathetic neuron cell bodies, the preganglionic ones, are either in the sacral spinal cord or in the brainstem. And the postganglionic neurons always release acetylcholine as a neurotransmitter. That is, they are cholinergic. This image contrasts the thoracolumbar sympathetic division on the left with the parasympathetic craniosacral division on the right. Of course, both divisions are bilateral. Only the preganglionic pathways are illustrated. That is, the course that the preganglionic neuron takes to various ganglia, which are shown as colored circles. Thus, these thoracolumbar preganglionic neurons trigger distribution of sympathetic postganglionics to the entire body by synapsing in these various autonomic ganglia. This ganglion goes to the head, these ganglia go to thoracic viscera, these ganglia along the sympathetic trunk chain go to the body wall and limbs, these ganglia in the abdomen go to abdominal viscera, and these ganglia here supply pelvic viscera. Parasympathetic innervation to pelvic viscera originates in the sacral spinal cord, and the preganglionic axons follow this path to the pelvic ganglia within a pelvic plexus. Preganglionic parasympathetic neurons in the brainstem send their axons out through 4 cranial nerves. The 10th cranial nerve, which is the vagus, innervates all thoracic viscera and most of the abdominal viscera in the abdominal cavity. It does so by sending preganglionic axons all the way to the visceral organs and synapsing on microscopic terminal ganglia located in the walls of those organs. Functionally, sympathetic and parasympathetic innervations typically have opposite actions on the structures that they both innervate. So, for example, the sympathetic division will dilate the pupil, parasympathetic will constrict it. Sympathetics will dilate bronchioles, parasympathetics will constrict them. Vessels in skin and muscles don't receive parasympathetic innervation, so they must be controlled by different degrees of sympathetic stimulation. Some postganglionic sympathetic neurons are cholinergic. It is recommended that you recall innervation effects of sympathetic and parasympathetic on these various visceral structures, not by memorization, but by deduction, based on the fight or flight role that the sympathetic innervation has and the opposing parasympathetic effect. Imagine a life-threatening event, meeting a bear in the woods. Pupils will dilate to gather more light. The heart rate will increase and bronchioles will dilate. There is no time to defecate or to urinate. Of course, the sphincters contract because they always have opposite effects from the visceral walls. Some effects are less obvious. Ejaculation, for example. Ejaculation makes sense because constriction of the ductus deferens during ejaculation is accompanied by contraction of the bladder sphincters to preclude urine contamination of the ejaculate. Since there is not enough blood to fill all capillary beds, blood has to be shifted from skin to muscles in case of fight or flight situations. And of course, there is no parasympathetic innervation to some of these structures. Next, we want to trace autonomic pathways to various viscera. beginning with the parasympathetic pathways. We trace pathways by first locating the synapse and then identifying the postganglionic nerves from that synapse to the target organs and the preganglionic pathway from the central nervous system to that ganglion. Parasympathetic innervation to the head comes through three cranial nerves. The oculomotor supplies pupillary constrictor muscles in the iris. The facial nerve supplies the lacrimal and nasal glands and two salivary glands. The glossopharyngeal nerve supplies the remaining two salivary glands. Preganglionic neuron cell bodies that comprise the parasympathetic nucleus of the vagus nerve send their axons through the vagus nerve to terminal ganglia in thoracic viscera and most of the abdominal viscera. The vagus nerve innervates abdominal viscera supplied by the celiac and craniomesenteric artery. This cartoon shows in green vagal preganglionic axons to thoracic viscera, namely the heart and lungs. The axons run down the vagus nerve through the vagosympathetic trunk, and then they exit the vagus nerve as branches that run directly to thoracic viscera. Thus, the heart and lungs are receiving branches bilaterally from the right and left vagus nerves. This dissection shows the vagosympathetic trunk on the left side. It continues as vagus nerve beyond the middle cervical ganglion. Here it's giving off a recurrent laryngeal nerve around the ligamentum arteriosum. And then the vagus nerve is continuing. It divides into a dorsal branch and a ventral branch, and right and left dorsal branches will form a dorsal vagal nerve trunk, and right and left ventral branches will form a ventral vagal nerve trunk. But in here, and not showing up very well, are branches that would leave the vagus nerve and supply the lung. This is the root of the lung transected, and the heart, along with thymus and other viscera. Now we are considering vagal innervation of abdominal viscera. The preganglionic axons will run into the abdomen, and the postganglionic neurons will be in terminal ganglia. So here we see a right vagus nerve in green. It passes through the thorax, into the thorax, divides into dorsal branches and ventral branches, and right and left dorsal branches form a dorsal vagal nerve trunk, and right and left ventral branches form a ventral vagal nerve trunk. These trunks enter the abdomen and either run directly on stomach and liver, for example, or they reach the other viscera by running on plexuses associated with the celiac and craniomesenteric arteries. The dorsal vagal nerve trunk runs on those arteries. The ventral vagal nerve trunk tends to end in the liver and stomach. This dissection shows abdominal viscera. Dorsal is to the bottom, ventral is toward the top. The diaphragm has been incised and reflected, exposing both the thoracic and abdominal cavities. This is the esophagus coming in and joining the stomach. This is liver. Here's a little bit of diaphragm, the tendinous part. This is spleen, greater omentum. This is kidney. And running on the surface of the esophagus is a ventral and a dorsal vagal nerve trunk. You can see that the dorsal vagal nerve trunk has been formed by left and right, dorsal branches of the left and right vagus nerve. And you can see that the dorsal vagal nerve trunk is joining nerve plexuses associated with the celiac and the craniomesenteric arteries. So these arteries are branches of the aorta, which is not hidden by viscera, and you can hardly see the arteries because the plexuses are plastered on them. And so the dorsal vagal nerve trunk hooks on and innervates all the viscera supplied by these two arteries, synapsing on terminal ganglia located within the wall of the visceral organs. preganglionic parasympathetic neuron cell bodies in the sacral spinal cord in S1, S2, S3 give rise to parasympathetic innervation to pelvic viscera, including the descending colon. The synapse takes place in pelvic ganglia within the pelvic plexus, and then the postganglionics run directly in branches to the various viscera. The preganglionic pathway then begins in the sacral spinal cord. Its axon runs out the ventral root, the spinal nerve, the ventral ramus. It's part of the lumbosacral plexus, and one branch off the lumbosacral plexus is the pelvic nerve, which collects all of the visceral efferent parasympathetic preganglionic axons that are traveling down to the pelvic plexus. The pelvic nerve will also have visceral efferents that will go back to the spinal cord. This dissection reveals the pelvic plexus. It's plastered to the exterior surface of the parietal peritoneum, lining the pelvic cavity. This is the urinary bladder. This is the ureter coming in. This is the urethra. This is the rectum going back. These are postganglionic branches coming from pelvic ganglia, such as these little spots that you see here. The ganglia are quite small. The plexus is fed by the pelvic nerve, hidden by these vaginal vessels now, that comes down as a branch off the lumbosacral plexus and comes down and feeds parasympathetics into the pelvic ganglia and pelvic plexus. Also, this is the hypogastric nerve that we'll see is conveying sympathetics to the pelvic plexus to be distributed to the various pelvic viscera. So next we want to describe sympathetic pathways, and here we're looking at preganglionic sympathetic pathways. Since the sympathetic pathway goes throughout the entire body, there are a number of ganglia that sympathetic preganglionic neurons can synapse in. But all of the preganglionic neurons have to come from the thoracolumbar region, the thoracic region and craniolumbar region of the spinal cord. The whole body is compressed within this region. So these preganglionics will go to the head, and these will go to the neck, and these will go to the thorax and abdomen and pelvis and tail, and all along here preganglionics will go to the body wall and limbs. This cartoon shows a preganglionic sympathetic neuron arising in the thoracolumbar spinal cord, traveling through the ventral root, the spinal nerve, down the ramus communicans to the sympathetic trunk, where it may or may not synapse depending on where it is going. But regardless of what ganglion the preganglionic pathway is going to, it will always begin the same way: ventral root, spinal nerve, ramus communicans to the sympathetic trunk. This drawing shows sympathetic ganglia on the left. They are colored yellow. Preganglionics will go to one of these ganglia, one or more of these ganglia, according to what is being innervated. Preganglionics will go to this ganglion for the head, these ganglia for the thorax, these ganglia for the body wall and limbs, these ganglia for abdominal viscera, and these ganglia for pelvic viscera. We will want to trace pathways to 6 body regions: the head, the neck, the thorax, the abdomen, the pelvis, and the body wall and limbs. Beginning with the head, the synapse for sympathetic innervation of the head is the cranial cervical ganglion. Postganglionics will run on the internal carotid or external carotid in nerve plexuses on those arteries. This cartoon shows the preganglionic pathway. The axons run through the first thoracic rami communicantes. They run through the ansa subclavia, up the cervical sympathetic trunk, and then synapse in the cranial cervical ganglion. Postganglionic pathway is axons from the cranial cervical ganglion running on the internal carotid artery or the external carotid artery, on nerve plexuses of those arteries. And this happens bilaterally. Notice that this preganglionic pathway runs through the cervicothoracic ganglion and through the middle cervical ganglion without synapsing. Recall that we define ganglia as an enlargement of a nerve. So these ganglia have nerve fibers that run through them. This dissection shows a cranial cervical ganglion. This is the cervical sympathetic trunk. Here it separates from the vagus nerve. This is the vagus nerve coming caudally, and this is the vagosympathetic trunk. Here's a cranial-laryngeal branch to the larynx. These branches off the cranial cervical ganglion may be running to the internal or external carotid artery plexuses. This is the common carotid artery. This is the internal carotid artery. The external carotid artery is here. The synapse for innervation of the body wall and limbs is the synapse involving the sympathetic trunk ganglia. The viscera in the body wall and limbs are mainly vessels, smooth muscle associated with vessels. So the preganglionic pathway would be, as it always is, ventral root spinal nerve down to the ramus communicans. In this case, it synapses in the ramus communicans on sympathetic postganglionic neurons. The best way for those neurons to get to the body wall is to go right back up the ramus communicans, and then they can go out with either the ventral branch or the dorsal branch. Thus, the purpose of all of these ganglia along the sympathetic trunk is to innervate viscera in the body walls and limbs. So we are just showing the rami communicantes that had preganglionic axons running down to the sympathetic trunk. But now we're saying that rami communicantes will also have postganglionic axons running back up the sympathetic trunk to the spinal nerve. And we have said that virtually all spinal nerves have 4 primary branches, including a ramus communicans. And now we're saying that all rami communicantes have postganglionic axons in them, which are coming from the sympathetic trunk and going up to the spinal nerve to run out with dorsal and ventral branches. But only in the thoracolumbar region do the rami communicantes have preganglionics running down to the sympathetic trunk. This dissection shows the sympathetic trunk in the thorax. You can see rami communicantes, which attach sympathetic trunk to spinal nerves. You can see a large cervicothoracic ganglia. The other ganglia are not very obvious. Vessels in the skin and muscles of the neck region are innervated by neurons in the cervicothoracic ganglion. The collected axons from the cervicothoracic ganglion run through a canal in cervical vertebrae as a vertebral nerve. And the vertebral nerve gives off branches as rami communicantes to cervical spinal nerves. The postganglionic axons will run in the dorsal branches or the ventral branches of cervical spinal nerves. This dissection shows the sympathetic trunk in the thoracic region, the cervicothoracic ganglion, connected by an ansa subclavia around the subclavian artery to the middle cervical ganglion associated with the vagosympathetic nerve trunk. And these are rami communicantes, but this is the vertebral nerve. These axons leave the cervicothoracic ganglion and run with the vertebral artery through a canal in cervical vertebrae. The sympathetic pathway to thoracic viscera also synapses in the cervicothoracic ganglion and the middle cervical ganglion. Postganglionic branches run as direct branches off the ansa subclavia to the heart, lungs, and esophagus when the esophagus is smooth muscle. This cartoon shows the diagrams, the entire pathway. Caudal to the head and neck, we have neurons that run through the ventral root spinal nerve down the ramus communicans to the sympathetic trunk. They run through the sympathetic trunk and synapse either in the cervicothoracic ganglion or the middle cervical ganglion. These ganglia give off direct branches, come off the ansa subclavia or off the parent vagus nerve, back to the heart and lungs in particular. This dissection shows the cervicothoracic ganglion and the middle cervical ganglion. They're connected by two limbs of an ansa subclavia. And here we see direct branches coming off the ansa subclavia and perhaps down here that are going back to innervate thoracic viscera, particularly the lungs and heart. For abdominal viscera, the synapse takes place in prevertebral ganglia. These are ganglia that are located on plexuses, on blood vessels that are supplying the viscera. The ganglia and plexuses are named for the artery on which they are found. Thus we have a celiac, craniomesenteric, caudalomesenteric, renal, and gonadal ganglia and plexuses. Here we see the pathway diagrammed. The preganglionic axon runs out ventral root, spinal nave, ramus communicans down to the sympathetic trunk. But it does not synapse in the sympathetic trunk. It takes a nerve from the sympathetic trunk to plexuses on the arteries, and such nerves are named splanchnic nerves. We have a major splanchnic nerve and a minor splanchnic nerve that goes to the celiac or craniomesenteric plexus, lumbar splanchnic nerves that go to vessels caudal to those. The ganglia are named for the plexus they are within, and the plexus is named for the artery they are on. So we have a celiac artery, a craniomesenteric artery, etc. Actually, we have right and left celiac ganglia, two ganglia in the one plexus. The major splanchnic nerve also supplies the adrenal medulla, causing it to release adrenaline. This cartoon shows the preganglionic pathway to the celiac nerve plexus and right or left celiac ganglia. So here bilaterally we have a major splanchnic nerve that contains preganglionic axons or minor splanchnic nerves. Those preganglionics synapse in this ganglion. The postganglionics run on vessels to supply what the celiac artery supplies, namely liver, spleen, stomach, gallbladder, pancreas, etc. The same preganglionic pathway will go to the craniomesenteric nerve plexus on the craniomesenteric artery. The preganglionics will synapse in the craniomesenteric artery. The postganglionic axons will run on the nerve plexus to supply cecum, ascending colon, transverse colon, small intestine, pancreas, for example. This dissection shows the celiac artery and the craniomesenteric artery. They come off the aorta, which is not visible. You can hardly see the arteries for this mass of nerve plexuses surrounding them. They pulled off the celiac artery, but they're really still around the craniomesenteric artery. In the celiac plexus, there's a left celiac ganglion, and here is a horseshoe-shaped craniomesenteric ganglion. Postganglionic axons from these ganglia run on the vessels to all the visceral organs supplied by these vessels. Meanwhile, up here is the sympathetic trunk, and here we see the major splanchnic nerve peeling off and running down to these plexuses to synapse in the celiac, right or left, or the craniomesenteric ganglion. We also can see some minor splanchnic nerves. The major splanchnic nerve also innervates the adrenal medulla. This is the adrenal gland. The last region to which we want to trace sympathetic pathways is pelvic viscera. These are innervated by the synapse in the craniomesenteric ganglion, or in some cases in pelvic ganglia. The preganglionic pathway is, as usual, down the ramus communicans, through the sympathetic trunk, but now in a splanchnic nerve that's caudal to the major and minor, and these are called lumbar splanchnic nerves, and there may be about 4 of them. They come back, these preganglionics come caudally then and synapse in the cranial cervical ganglion. Since there are bilateral pelvic plexuses, there are 2 nerves that are going to leave the caudal mesenteric ganglion. And these are called hypogastric nerves. So there's a left and a right hypogastric nerve that carry postganglionics mainly back to the pelvic plexuses, where they will run out with branches of those plexuses to urethra, the urinary bladder, the rectum, the vagina, and so forth. Here we see the entire pathway diagrammed. We have preganglionic neurons running out ventral root, spinal nerve, ramus communicans, down through the sympathetic trunk, through lumbar splanchnic nerves to synapse in the caudal mesenteric ganglion. The postganglionics will run via the right or left hypogastric nerve back to the pelvic plexus, and then out through branches of the plexus to pelvic viscera. This dissection shows the caudal vena cava, the renal vein, the kidney. This is the aorta. And here we see the caudal mesenteric artery, which goes out to the descending colon and rectum. On the nerve plexus on that artery is the caudal mesenteric plexus, and there is a caudal mesenteric ganglion in that plexus. That ganglion is fed by lumbar splanchnic nerves, here's one here, that bring preganglionics down to the plexus. The synapse in the plexus then gives rise to postganglionics, which go through left and right hypogastric nerves to the left and right pelvic plexus. And this dissection shows the pelvic plexus plastered on the lateral surface of the parietal peritoneum of the pelvic cavity. You can see all the branches that go to the various pelvic viscera. And here we see the hypogastric nerve coming in on this left side. Its branches join the pelvic plexus and run out to the various viscera. So this concludes this peripheral nervous system highlight screencast concerning the autonomic nervous system.